All right, our final video of Unit 1. All of the work we've done with exponents and scientific notation wraps up here. The biggest concern I have is whether you can see the questions. My printer is a little low on ink, so the questions themselves are a little light, but there are only 3 of them, and I think we can get through these pretty quickly. In every word problem we've dealt with so far, it seems the biggest challenge is deciding what to do in each question. So this one says a human body contains different types of cells and different sizes. A reproductive cell has an average volume of, here's a number in scientific notation. A red blood cell has an average volume of another number in scientific notation. Which cell type has the greater volume? Okay, and watch this, estimate how many times greater. Here's that phrase, how many times? I feel like how many times can they ask us this before we use the same strategy every time? So here's what we're gonna do. We're going to, in this problem, once again, set up our situation where we have the smaller value, the times bigger, and the greater value or the bigger value here. And because I'm zoomed way in, I'm gonna try not to work below the screen here. Here's what I know for sure. How many times is the thing we're trying to find? That's my question mark. I look at these 2 values and the 2 is bigger than the 1 and they're both written in scientific notation. So 1 times 10 to the second is my greater value and 3 times 10 to the first is the smaller value. I also know that when I'm dealing with these problems, this is a division problem because I do the bigger number divided by the smaller number. So big divided by small. So here we go. I have 1 times 10 to the second divided by 3 times 10 to the first. Now, when I do my division, I get approximately, right now, it does say estimate, so we're going to use an estimate. I do get 0.3 repeating. So for now, I'm going to go ahead and just leave it as 0.3. That's different, but it's an estimate. And when I do my 2 minus 1, I get 1. Now that's not in scientific notation, so let's make it write 1, down 1. So write 1, down 1. So 3 times 10 to the 0, and 10 to the 0 equals 1. So 3 times 1 equals 3. Let's make sure that's on the screen. It is. So now I know that how many times greater? It's 3 times greater. And there's only 2 choices. So it's not the first option. It can't be the second option. And now it only matters, estimate how many times greater. I suppose we have to answer which cell type has the greater volume. The greater volume had the greater exponent. The greater exponent went along with a red blood cell. So red blood cell, 3 times greater is our correct answer. And what you're going to see is 2 more times in a row, and perhaps we'll speed this up a little bit. The same situation will occur every time you do a problem in Unit 1, Day 18. I'll switch colors of pens. Once again, scientists collected a 1-liter sample of seawater, examined it to see how many viruses, bacteria, phytoplankton, and protozoa it contained. The scientists found there were this many protozoa and this many viruses. How many? Here it is. How many times greater was the number of viruses, the number of protozoa? And in the Get More Math piece, there is a rectangle right here to answer times greater. We're going to go ahead and use this space. We're also going to pay attention to the fact that it says estimate by rounding to the nearest whole number. So this one does not want scientific notation. But that doesn't change how the setup occurs. So it's small times the number of times is the big. How many times greater is my question mark. The bigger exponent goes in the big space. The smaller exponent goes in the small space. Sounds like my neighbor's cutting the lawn. And we're gonna go big divided by small. So 3 times 10 to the 9th divided by 5 times 10 to the 5th. 3 divided by 5 is 0.6. 9 minus 5 is 4. And because this isn't in scientific notation, I'm going to go write 1, down 1. So I get 6 times 10 to the 3rd. And now this is where I have to be careful. Estimate by rounding to the nearest whole number. That means do not type in scientific notation, but instead, this is simply 6 times a 1 with 3 zeros. So that's 6 times 1,000 or 6,000. No need to round that off because that's already a whole number. So we have our answer of 6,000. And the final question is the smallest to read. It says Rob's teacher posed the following question to the class. Which is greater, one of these things, attokelvins, or 1 zeptokelvins? And here it is. How many times greater is it? How many times can we do this question? So same exact setup every single time. How many times greater? The smaller number goes here, so we're looking for the smaller exponent. The smaller exponent is the one that's more negative, so 1 times 10 to the negative 21. The larger exponent goes on the greater side, 1 times 10 to the negative 18th. And just like every other example, it's big divided by small. So the big, 1 times 10 to the negative 18th, divided by the small, 1 times 10 to the negative 21st. 1 divided by 1 is 1. Negative 18 minus negative 21 is 3. And 1 times 1,000 is 1,000. So I know that I'm looking for the number with the 1,000. In this example, I only see one that even lists 1,000. So therefore, I know my correct answer must be the first choice. That's how you'll do every problem in Unit 1, Day 18 with the same key phrase that we've seen so many times before. How many times greater or less than? How many times greater? Good luck.